we'll talk about what a domain name is and how a domain name is used to get an IP address. So host names and domain names. Each host on the internet has a unique IP address. For instance, the one I'm showing right there. So that's unique, supposed to be. Now, IP addresses are needed to send messages, right? So if you want to send a message to a host, you need its IP address, and the IP address is included in the IP header of the packet that's being sent. The IP addresses, though, are not easy for humans to memorize, right? We don't memorize numbers that well. I mean, some of these numbers I do. So I do remember some IP addresses, actually. When I was a kid, I used to remember IP addresses all the time. But now, it's a pain to remember all the IP addresses that you might want to access. So we use domain names instead. Pseudonyms. So ics.uci.edu or cnn.com, something like that. Humans can memorize that. So in order to send a message, each domain name that the human knows has to be translated into, has to be resolved into an IP address to send the packets. So the human types in the domain name, and then that has to get automatically converted into an IP address that can be included in the packet header, and the message can be sent. So for that, we use what's called Domain Naming System, DNS. So DNS is basically a big hierarchical naming system to determine IP addresses. So basically, imagine a gigantic table. Imagine a big table that maps domain name to IP address. Now, there isn't just one table. It's because this is worldwide network, right? So it's actually a hierarchy of tables in different machines across the world. Okay, and it's arranged. It's not that complicated. We're not going to go into the details of the protocol, but the idea is that when you at your machine, you want to go to a web page, say CNN.com. That CNN.com has to get converted to the IP address of CNN.com, so you perform what's called a DNS lookup. So now when I say you perform, your web browser performs this. Your web browser sends a message to a DNS server and says, look, what is the address of CNN.com? And if this this domain name server, this DNS server, knows that address, it sends it back to you. It sends the IP address back to you. If it doesn't, then it goes and asks another DNS server higher up. Said, look, do you know where to find this? Where this IP address is? And if it knows, then it sends it back. If it doesn't, it asks another DNS server, and so on. Eventually, you get to the top level DNS server, and that will be able to find any address. But that system, we won't go into the details, but there is what's called this process of a DNS lookup, where your machine sends out a request to say, look, for this domain name, what is the IP address? And eventually, it gets the IP address back. So that's the DNS lookup. And that has to happen every time, at least the first time, every time you go to a domain name, that has to happen. Now, for performance reasons, you don't want to do this DNS lookup every time you go to a website if you can help it. So if I go to CNN.com once, rather than looking it up every time I type in CNN.com, it stores it in a cache, in a local memory, right? It stores that address in local memory, so that the next time I go to CNN.com, it doesn't have to look it up again. So that saves time, performance-wise. But this DNS lookup has to happen at least once. So this DNS lookup usually is performed by your tools, by your web browser, let's say, behind the scenes. You don't have to do it manually. But you can do it manually on a Linux box just to see how it works. So you can use what's called NSLookup. So if you go to your Raspberry Pi or any Linux box, and you type NSLookup and you give a domain name, like here, NSLookup www.google.com. So we see some data here. First, you see server and address. So what that's telling you is where the DNS server is. So what that means is that whatever domain you're in, there's a DNS server associated with your domain, right? Now, there's a default DNS server, or you can specify it if you wanted to, but I didn't specify it. This is my default for my domain. The server's address is 192.168.1.1. And see where it says address, it's the same address, same IP address, and then it says #53. So that #53 is the port number. So 53 is the port number associated with DNS. So if I want to do a DNS lookup from my machine, I have to go to 192.168.1.1 and port number 53. I go to that machine at that port, and there's a DNS server waiting there to receive my request, my lookup request. So that's where the server is. But then where Google is, you see at the bottom, named google.com, address, blah. So that tells you where, at least where their outside server is. So it performs a lookup and it gives me the answer and prints it to me. So you can do that manually if you want to. And when I say back in the old days, I used to memorize IP addresses. Back when I was an undergrad, the network wasn't necessarily as reliable as it is now, and the server itself might be down. So there would be times where I'd try to connect. This is pre-web, before internet, okay? Not before internet, but before you had web browsers, before you had the web at all. But you'd say I want to connect to do email or something like this. So when you want to connect, you give a domain name, and it has to first do a lookup to the domain name server. But if somehow your connectivity to the name server was down, then you couldn't connect to wherever your actual destination was. Just because the name server connection was down, you couldn't get the IP address. So sometimes it was useful to memorize the IP addresses so that you could just type that in, and you don't have to bother with the name server connection. So even if the name server was down, you could still make your connection. So for that reason, I memorized. People would memorize some addresses. Thank you.